Hey there, happy Wednesday. So today we're going to be looking at convection currents. And so the first thing you're going to do is you're actually going to click on this video and you're going to watch it. And when you're done, in your notebook, I want you to write the word convection current as your title, and then just do a sketch, a drawing of what you think convection currents look like. So then the next thing we're going to do is I just want to talk to you about, so this is the layers of the earth, the inner core, the outer core, and the mantle. The core is solid and very hot. So the mantle itself will heat up and then it rises. And then it hits the crust of the earth, the surface of the earth, it cools and drops back down. And heats up and rises and cools and drops back down. And where two of these convection currents are coming together and then separating, that's where you're going to have tectonic plates pull apart. That's going to be a divergent plate boundary. And that would be where, for example, we would have the mid-Atlantic ridge that goes up through Iceland. Over on the sides, you would have one plate is going to subduct under the other at a convergent plate boundary, or you might have two plates meeting, two continental plates, and making mountains like the Himalayas. And that's where the convection currents are going towards each other. Okay. And so this image here is of the ocean floor, and you can see this mid-ocean ridge. This is a divergent plate boundary that goes up through Iceland. And then look up here on the Aleutian Islands. You can see this sort of dark shadow, and you can see it along the coast of South America. So what that is that's what's called a trench. And these trenches are unbelievably deep. And it's where there is a subduction zone, okay, where one plate's subducting under another. And they're so deep, in fact, that this is where submarines will hide to spy on other countries in these trenches because they're so deep. So for our activity, you're going to complete this doc that's entitled Convection Currents. And let me exit here and I'll show you the doc itself. So this is the doc itself. And for each section, you're going to just click on the video. And like this first one, you'll click on this video and then it says name the currents that move tectonic plates, and you will type right here. Okay. This one you'll click on and find an image of convection currents and paste it here. So you'll just paste an image. For this one, you're going to copy and paste an image of the layers of the earth. Then, and then that same one, after watching that one, it's a model of convection currents. And so then you're going to evaluate this model. Okay, what's one good feature of the model and what's one poor feature that doesn't make it a good model of convection currents in the mantle, moving tectonic plates? Same thing here. Is this a good model for convection currents? Explain why or why not. Then in your notebook, I want you to draw convection currents in the mantle. Okay. And then finally, and I'm going to pay really close attention to your answer here, I want you to now explain to me why tectonic plates move, okay, based on all this information. And so that's what we'll be completing. Another reminder, my Pangea, I need those from everybody. Another reminder about office hours. And that's it. So remember that I have Science Zoom at 1 o'clock. But I know some people are not getting home in time, and thus this video. See you soon.